myself Pushkar. Today we are going to learn a new topic of mathematics called domain of the function. So let us consider a real-time example before going into mathematics directly. If we have a 4-seater car, then how many people can be seated in that car? Only 4. So I will say the capacity of that car is 4, therefore domain of that car is 4. In case of a 50-seater bus, since the capacity is 50, I will say the domain is also 50. So what I have defined, that domain is basically the capacity of a particular vehicle. Similarly, in mathematics also, when we say different functions, every function has some capacity to include the values. So that capacity, I will call that all acceptable values of that particular function is called domain of the function. So let us define domain. Domain will define as all acceptable values of function. It is called domain of the function. Let us write y equal to fx as a function. Here this right hand side of equality is called the input side, while the left hand side of the equality is called output side. We can substitute any value of this function, that is any value of this variable x, on the right hand side of this equality, and corresponding to this right hand side we will obtain the value of the function, that is the value of y on the output side. So this is how we find the domain. Now let us take real-time example. Suppose y equal to x is a function and we have to find the domain of this function. Then we will analyze this right hand side of this equality and then we'll decide that how many values of x are acceptable in this function y equal to x. So suppose we substitute x equal to 0, we will obtain y equal to 0. Whensoever we substitute the value of x, correspondingly the same value of y is obtained. And there is no problem in substituting any real number in place of this x. Therefore, since there isn't any problem in substituting the values on the right hand side of this equality, we will say that domain of this function is all real numbers. Let us take another example, y equal to x square. Now, when I substitute any value of x, say x equal to 0, I will get corresponding value of y. When I substitute x equal to minus 1, I will get y equal to 1. X equal to 100, I will get y equal to 100 square. X equal to minus 100, I will get y equal to minus 100 square, and so on. Here also there is no constraint on this x that we can't substitute this value or a particular value in this x. So here also the domain of the function is all real values. Let us take another example, y equal to 1 by x. Now here in 1 by x we can't substitute every value, that is we can't substitute every real number. Why? Because if we substitute x equal to 0 here, then we will obtain 1 by 0 which is undefined. So x equal to 0 is not acceptable. Other than x equal to 0, if you substitute any value on the real number scale, you will find that y obtains the corresponding value, that is y obtains a defined value. So other than 0, every value is acceptable. So when we have to write domain of the function, we will say that domain of the function is all real values apart from or other than. In this curly bracket, I am going to write that value which is not acceptable. In this case, 0 is not acceptable. So the domain of function becomes all real number other than 0. This is basically the overall framing of domain, that how we find the domain of any function. In more complex function there are certain ways of finding the domain, but overall we are going to do the same thing in this complete unit. So hope you have enjoyed this domain. Thank you.